Assalamualaikum warahmatullahi wabarakatuh. Okay, this is the video for chapter 3. So chapter 3 is on process design and safety. So basically in this video I will cover on 3.1, which is safety. So in chapter 3 we have 5 subchapter, which is safety, process safety, chemistry and separations, unit ratio, material balance, and detailed flow sheets. So basically all these subchapter basically you have learned inside subject semester 1 if I'm not mistaken, and also subject in semester 3 for material balance, separation in semester 4. So basically I will just briefly explain about this topic. So I will relate it with the what we gonna learn, what you gonna do for your assignment. Okay, so basically safety is a safe design and operation of facilities of importance to every company. It involved in the manufacture, not limited to fuel, chemicals, and pharmaceutical. All company, all industry need this safety, because when we prioritize the safety, we will ensure that our worker is safe to work inside our company, and also the other surrounding resident, consumer also, we can ensure that their life is not affected or harmful by our company operation. Okay, so the process must be acceptable, safety and environmental, because okay, the safety is required by law. As we all know, we have DOSH, NIOSH, DOE. So all these agent is a agency, the bodies for the safety. So okay, the other reason is the cost, human, social, economic, of non-compliance can be catastrophic. So sometimes the incident happen industry involve the explosions. This explosion basically is not effect to the person life only, but the cost on the equipment operation also affected. So when there is an explosion occur, the equipment could be damaged 100%. So that company have to bear that cost to do a restructure back and to do a maintenance on the equipment. Okay. So the other reason is moral and ethical obligations. Okay, so the most major chemical plant safety legislation is this one is Akta Keselamatan dan Kesihatan Pekerja. This one is DOSH. So we also have a FMA, which is Akta Kilang dan Jentera. We call it as a Factory and Machinery Act. So also we have a Akta Petroleum. Okay, so basically it's depend on the company. If your company dealing with the petrochemical or petroleum, yes, you need to consider this Petroleum Act. And if that company is produce a different product from petroleum, that company also have a different act to comply in order to make sure their operation is safe. So it's depend on the company itself. So but for all the company in Malaysia, this DOSH, Akta Keselamatan dan Kesihatan Pekerja, all the company must follow. And also we Akta Kilang dan Jentera. Okay, chemical plant hazard. So basically, what you're gonna do is to design a safe process or product. We need to understand and mitigate the associated hazard. So example of hazard, we have a material hazard. So the material hazard could be toxicity, flammability, incompatibility. The other hazard is process hazard. So the list of process hazard is overpressure, explosion, loss of containment, noise. So this one you already learn inside plant safety and occupational health, right? During your semester 1, if I'm not mistaken. So this one also toxicity also you already learn. Okay, so let's have a look one by one hazard. Okay, now we move to toxicity. So, for your information, almost every chemical is toxic in a certain amount. So, we have a allowable amount for you to use the certain chemical. So, when you reach a higher limit amount, it could be toxic to your health, to surrounding, and also to the ecosystem nearby your company. So, for your information, chemical plants tend to have large enough amount of chemical to cause serious concern for workers and local residents. So, normally in a chemical plant, they will use a raw material, a chemical, for example, raw material or product in a big amount like 1,000 tons. Can be per day or can be per week. So, in order to do a process design, you need to consider first thing is elimination or substitution of the most hazardous compound, and second you need to do a prevention of releases. So this one, if you find that you will release a harmful chemical from your company, you need to come up with a prevention measure. If to be safe, better you eliminate first the hazardous compound or material that you use inside your operations. Okay, the other process design need to be considered is containment, disposal, ventilation, and also emergency procedure. So all of this list basically you already learn inside the process safety subject. So I think you already familiar with all of this. Okay, so now I will move. So for the acute effect, normally the result of short-term exposure. Okay, for the chronic effect, the symptom develop over a long period of time, such as cancer. So basically, this is the result of the long-term exposure. Okay, the other thing you need to consider inside the toxicity is lethal dose. This one actually you already learned inside the process safety. There is a calculation, right, to calculate the lethal dose. So basically, lethal dose is the dose at which 50% of test animals are killed. Okay, the other thing for under toxicity is threshold limit value, TLV, or permissible exposure limit, PEL. So basically this TLV and also PEL you can calculate based on the formula that you learn inside the process safety subject before. So basically concentration that is believed the average worker can safely be exposed is around 40 hours per week. Okay, so this is the table get from OSHA on the PL and also lethal dose for compounds such as carbon monoxide, carbon disulfide, chlorine dioxide, chloroform. You can read all the information inside this toxicity data. Okay, so next moving to flammability. So a fire requires three things. So in order to for us to start a fire, we need to have oxygen, fuel, and also heat. So these triangles shows you that if you have all of these three elements, then the fire can be started up. Okay. So possible ignition source include for the electrical equipment such as motors, actuator. So usually this equipment specified as a flame proof or non-sparking when fuel are present. So next possible ignition source is open flame from furnaces, incinerator and flare stacks. Okay, next is static electricity. So this static electricity can be from any flow, such as pipes, vessel, or flanges. So if you notice inside the chemical plant, normally these pipe, vessel, and flanges are always grounded. Okay. Lastly is miscellaneous sources like matches, lighters, and mobile phones. So basically inside the chemical plant, all these three cannot be used. So if you're working inside a plant, so in order you to contact with the outside people, you can go to the control rooms. Inside the control rooms there is a uh, telephone that provided for the workers to contact the outside people. So the flammability definition, we have flash point, auto ignition temperature, and also flammability limits. So flash point, in a simple word, is the lowest temperature at which the material will ignite from the open flame. So for the auto ignition temperature is the temperature which the substance ignite in air spontaneously. So we have the flammability limits, which is highest and lowest limit. So for the highest and lowest concentration in air at normal temperature and pressure and Tp, at which flame will propagate through the mixer. So this one is depend on the substance or depend on the materials, the flammability limit. So you can basically all this information you can find inside the MSTS. Okay, now we move to the flame suppressions. So okay, for the flame suppressions, normally in designs of the chemical equipment or piping, we need to install the flame arrestor. So this flame arrestor is used to prevent a flame from propagating back from the vent. So basically it is installed on the van line of equipment that contains flammable materials. So basically we have a few design of these flame arresters. So this is one of the common design. So basic principle is provide high metal surface area to act as a sink for heat and free radical. So basically there is a arrestor element here. It depresses and quenches the flame front. Okay, next is incompatibility. So basically, for your information, normally, for example, if your company produce many type of product, so like what I experienced before, I'm working inside a painting and coating company. So we have so many grade of painting and coating. So for example, in my company, we have a alkyd, we have a unsaturated polyester, and also we have a acrylic. So these three product is a different type of product. So to produce these three product, we have to use different reactor, different adjustment tank, and also all the process unit is different, because the alkyd is a water-based product, meanwhile for the acrylic is a oil-based product. So we need to find the, in order, for example, like I take one like unsaturated polyester. Inside the unsaturated polyester we have so many grades. So all these grades we use a different type of raw material. So we need to study first the compatibility of the raw material, so that we don't use the wrong raw material in the wrong equipment. So that's mean by incompatibility. So this incompatibility can lead to loss of containment. It can cause a corrosion of vessel, internal or instrument, and also it can softening the gasket, seals and lining. So if the gasket, seal and lining is softening, it can cause the leaking or explosions or overpressure of the fluid inside the piping. So basically this incompatibility is one of the major sources of incident. Okay, so this is the material safety data sheet. This one you also already learned inside the process safety subject. So the function of this MSDS is contain the information needed to begin analyzing material and process hazard. Okay, the role of MSDS in process design. Okay, basically, I think you already familiarized with this role of MSDS. So I just briefly explain. So the MSDS is used to improve the intrinsic safety of process. It can use for eliminate incompatible mixture, substitute less hazardous chemical when possible. For example, like toluene instead of benzene as solvent. Okay, all this information we can get from MSDS. Okay, lastly, MSDS is used to ensure that design meet regulatory requirements such as vapor recovery, other emissions. Okay, design for material hazard. So this is what we seen inside a previous slide. So for the material hazard, we need to consider substitutions, containment, prevention of releases, ventilation, disposal, provision of emergency equipment. So for the substitution, okay, use less toxic hazardous. Containment, you need to design sound design of plant and equipment. For example, use welded joint instead of flanges. Okay, next, for the preventions of releases, you need to design of equipment for the disposable system and also disposable system. So this equipment can treat the releases first. So if the releases is the allowable limit, if the releases reaches highest limits as compared to the allowable limits, so it can be treated using the equipment that you have been designed. So for the ventilation, normally we use the open plan structured or engineered ventilation system. Okay, for the disposal, you need to use the effective vent stack and scrubbers So the scrubbers video I already post inside the Padlet. You can see the video to get the idea about the scrubbers. So for the disposal also, you need to have the collection and treatment of runoff water and liquid form release system. Okay, now we move to process hazard. Okay, the example of process hazard is overpressure. So overpressure occurs when mass, moles, or energy accumulate in a contained volume. So when it's accumulate at high concentration, high mass, or high energy, it can cause overpressure. So rate of accumulation determines the pressure rise. Process controls may not be able to respond quickly enough. So if the pressure is not relieved by pressure safety valve, then outcome could include vessel rupture, explosion, and other loss of containment. So basically, if you notice that inside our control lab or inside our equipment, normally we have a pressure safety valve on top of it or at the bottom of it. So basically, this pressure safety valve is used to relieve the containment, the accumulation of the material inside the tank or vessels to avoid the overpressure. So next is fire and explosions. A fire requires a flammable mixture and also an ignition sources to cause these explosions. Fire in chemical plant can quickly lead to damage to control system and equipment, and it also can cause overpressure, loss containment, and also explosions. Okay, can you think of possible sources of ignition on a chemical plant? So basically, the possible sources of ignition can be overpressure, leakage, or short circuit, and we have so many source of ignition actually. So this one basically we can identify by doing a risk evaluations. Okay, so this is the type of the source of ignition. Sparking of electric equipment, process flame, static electricity, lightning, vehicle, portable electrical device, welding and cutting equipment, miscellaneous sources. So basically for these miscellaneous sources, we already inside the plant is already banned. Okay, for the electrical system, like what you learn inside the process safety, the normal practice is you need to put the lockout tag out to practice these procedures to prevent the electric shock accidents. So when someone do a maintenance at the equipment, that person need to do this procedure in order to notify the other workers that the equipment is under maintenance. If not, the other workers will do operations. If they do the operations, the people that work at the maintenance site will get injured, or worst case, it can cause death or explosions. Okay. Okay, next is explosions. So this explosion is the sudden catastrophic release of energy causing a pressure wave. So explosion can be caused by ignition of flammable mixture like liquid, vapor, solids. So explosion also can be caused by release of thermal energy like boiler rupture, boiling liquid expanding vapor explosions. So the definitions of explosion, we have 4 terms inside the explosion, which is deflagrations, detonations, expansion factor, and also flame speed. So for the deflagrations, normally the combustion zone propagate at flame speed usually less than 30 meter per second. So the pressure wave generated usually less than 10 bar. So the principle of this heating mechanism is combustion. Okay, for the detonations, the combustion zone propagate at supersonic velocity, which is around 2000 to 3000 meter per second. So this detonation is the bigger explosion as compared to the deflagrations. So the principal heating mechanism is shock compression. Usually require confinement or a high intensity sources. So deflagration can turn into detonation when it's propagating along a pipe. Okay, next is expansion factor. We can measure the increase in volume resulting from combustion. Okay, this is the formula. So the maximum value of this E is for adiabatic combustion. For the flame speed, the rate of propagation of a flame front through a flammable mixture. So this rate of propagation is respect to a fixed observer. So for the explosion, there is a design implications. Okay, we need to design to prevent explosion from happening. So the equipment design must consider this one. So we need to design equipment to prevent the formation of explosive mixture whenever possible. So basically, it is advisable to operate outside the flammability envelope. Okay, next we need to consider the confined explosion as a pressure relief scenario and ensure that the PRV is sized to allow adequate relief load to prevent detonation. So basically, this PRV is according to the equipment size. If your equipment is bigger, you need to design a bigger PRV in order to support, to allow the adequate relief of load. Okay, the other design implication is use flame suppressor. So this one is flame arrestor just now to prevent the deflagration from propagating into detonation. Okay, now we move to loss of containment. So the primary means of protecting the public from toxic chemical is containment by the plant itself. So we have to contain the toxic inside our plant area only. So what is the loss of containment can occur? Okay, so it can occur due to the pressure relief, operator error, for example, leaving a sample point open, poor maintenance procedure, like failure to drain and purge properly. We don't consider the drain system. We don't design a proper drain and purge system. So it can cause a failure. And lastly is failure to put everything back together properly. Okay, next is leak from degraded equipment. So it can cause corrosion. So basically, for the equipment that need to use for the chemical that is corrosive, we have a certain material that we can use. So in order to design the equipment, we need to see the overall picture of the process itself. So whether we need to design a special equipment with a special material, so we need to know the consequence first. Okay, if the leakage happen, is the chemical can cause corrosion, and or whether it can damage the seal or gaskets. Okay, we need to consider all of this in order to prevent the loss of containment. Okay, so the other process hazard is noise. So as you all know that chemical plant can be very noisy. So this noise sound is come from a compressor, turbine, motor and solid handling. Sometimes pump also can come up with a noise sound. So if you exposed to this equipment for a long time, it can cause chronic effect like permanent damage to hearing. So you need to, basically inside the plant, you need to wear the ear protections like earbud or ear muff. So basically our hearing system can bear the noise less than 80 dB. So when the noise at the area is greater than 80 dB, you need to wear the ear protection. So permanent damage can be caused by noise greater than 85 dB. Okay, so basically inside this subchapter is a theoretical, the overview of the safety that you need to consider inside your plant design. Okay, in the next subchapter, I will teach on the risk analysis that you need to perform in order to do a plant design. Okay, that's it for now. Thank you.